So let's go over some terminology again. And this time I want you guys to answer me. What is a horizon line?
Where the sky meets the ground.
Sky meets the ground. Can the horizon line and eye level be the same line?
Yes.
Yes. Are they the same thing?
No.
No. Alright. What is the rule for 1 point perspective when it pertains to verticals and horizontals?
There's only one vanishing point.
There's only one vanishing point.
The verticals and horizontals don't converge.
They don't converge. What are the only lines that converge in 1 point? Think about it. You mentioned it earlier quite a few times. Lines that show column C, row 4. All the way in the back.
Okay.
Either one of you two. One of you guys got to answer it. Nope. Anybody think they know? Depth. Lines that show depth are the ones that converge in 1 point perspective. All right. Now, for any object in 1 point perspective, what is always the vanishing point? You two don't answer. Which one?
Reference.
Nope. Row 2. Column.
Center point?
Yep. What's the real name for center point?
Center vision.
There you go. Center of vision. All right. Don't be scared to answer the questions. If it's wrong, I'll tell you it's wrong. If you're right, it'll be right. Okay. I'm not playing devil's advocate with you guys yet. All right. What does the ground plane signify? Height. Height of what?
Object with the camera.
The object, the camera. What does the stationary point signify?
How far away that's from
Correct. Okay. It signifies how far away the camera is from the picture plane. Can I have a 2 point object in a 1 point grid? Yes. How many vanishing points? What is the max amount of vanishing points I can have in a grid? Unlimited. Good. Alright, so, see, you guys already know more than you thought you did. Feel a little better about it. So, you guys ready? Pull out your stuff, pull out your T-square, pull out your pencils. You guys are going to be following me this time around, because I already went through it once with you guys, and now you guys are going to be going through it with me, step by step. You guys, when I call units, you guys are going to see me call 5 units to the right, 5 units to the left. It just means you guys mark down 5 that way, so on and so forth. Sometimes I'll say go 3 units down for the ground plane, and then another 2 units down. That just means add on another 2 units below the ground plane to create your stationary points. All right? Okay.
What do you want me to do with the false teeth where I am?
That's fine.
You can still work.
It'll still work.
You just gotta turn it on the side.
Yeah. Make sure you guys got space. Take the stuff that you don't need off your desk. You can keep your drinks up there, your food, whatever, but make sure you have enough space to work. I would put your pencils in front of you, or put them somewhere where it's easy to reach, along with your sharpeners. Okay. I'll bring that trash can back in. We got 4 people. Sometimes. Alright. If you guys see me drawing on the walls, that's our little secret, alright? As you guys can tell up here, there are some marks and holes in the wall. Yeah, don't let that get out of here. I could potentially get in trouble, maybe. Yeah, good zone. Alright, so 1 point perspective, okay? One thing you normally want to start off with. Oh, by the way, my yellow is going to be your graphite, okay? Yellow will be your graphite, my blue is going to be your blue, my red is going to be your red. So, I'm going to start off with the center of vision line. What does the center of vision line represent?
Center of view.
Yeah, the center of your vision. Okay. Make sure you guys label it, CVL. Alright, next we are going to put in our eye level. We're not going to go above it quite yet, so we can put our eye level somewhat higher. So here is our eye level / horizon line.
Doesn't matter how high I level with it.
No, I just wouldn't put it, I would just give it a little bit of spacing so that you can label it. Because we're also going to put it in cone of vision, so you're going to want to be able to see it. Everybody's there? Now, I want you to go 5 down from the center of vision, and that will be your ground plane. 5 units down. So this is your center of vision, your CV, also known as your VP in 1 point perspective. Okay. At number 5, you're going to create your ground plane. What does the ground plane double as? Anybody tell me?
Measurement?
Your what?
Measuring line?
Measuring line. Okay. We are going to go 5 to the right, 5 to the left. Keep it 5, 5, 5, 5 for now. Everybody still with me on that? Alright. Now, our stationary point. What is the stationary point again? Anybody tell me? What's the stationary point again? Without looking at your notes.
From the grid to the object.
From the what?
From the grid to the object.
Of what?
The camera.
The camera. Alright, so it's the distance your camera is from the grid slash picture plane. Okay? So we are going to go another 3 down. Another 3 units down. Alright. So, what this is telling us is that our camera is 1, 2, 3, 4, 5 units tall. And it is 1, 2, 3, 4, 5, 6, 7, 8 units away from the picture plane. Okay? See how you can use that to help you figure out things in a photo? Right? So how does that knowledge come to help you? Let's say you take a reference photo, right? And you really like the composition that's going on in there, but you're having a really hard time replicating that composition. Well, you figure out where the eye level is, you figure out where the center of vision line is. Once you can average out using some just common knowledge, spatial relations for proportions in there, you can use that knowledge to figure out what's lined up with the eye level. There's your height already, right? Okay? After you figure that out, then you can take this knowledge to help you to figure out where your stationary point is. You can figure it because what is a cube again?
Also is equal.
All sides equal, right? And it doesn't matter what size the cube is. If you divide it in half, what is the angle measurement of those angles? 45 degrees, right? So, what do you think you are going to utilize to help you figure out the stationary point in a photo? The 45-degree measuring point. Because in order to find the 45-degree measuring point, where does that come from? It comes from the stationary point. Right? So, I am going to project my 45-degree measuring point. Right? And here's how you would utilize that in a photo. If the stationary, in order to find the 45-degree measuring points, you have to measure from the CVL outwards 45 degrees, right? Well, what angle measurement do you think is right here? That's 45 degrees. Okay. So, if you've already used the photo to figure out your eye level and your CVL and your center of vision, then you just have to find an object within the photo that is a square or a cube, and you can cut it to find your 45-degree measuring point. See where it hits the eye level. From there, you can trace it back to your stationary point. Okay? There's another way, but we'll get to that in a little bit as well. Now, we are going to connect these units of measure to the vanishing point because we need to show some depth. And I can already tell you, I have a bad human error up here. with me at this point? Alright, so next step. What I want you guys to do is to go from the opposite corner, the furthest corner opposite of the 45-degree measuring point, and connect a line to that 45-degree measuring point. If you guys ever run into a situation like this that I'm at, where your straight edge is too short, here's a technique to do. Go from your reference point or measuring points or vanishing points and create a couple guidelines. Like this. Make sure they're somewhat close to each other. Because now I don't need to aim for this guy. I just have to aim between these guys. Alright? Because if I'm aiming between them, so let's say if I do this, if I go up there, it's not going to converge at the same point. But if I aim between two of those lines, like so, and about right there. Like this. And I will continue this in a different color just for visual difference. If I aim like this between them, well, they're also going to converge in the same spot, right? All I did was I just drew a line that was converging between the two, right? That's one method. That's what's called an in-picture method. So let's say you have a drawing that's just this big. Well, your vanishing points are way on the outskirts. Are you really going to try to find something that long to connect you to that vanishing point? No. Just use this method. Just create a bunch of little guidelines to aim towards it. And once you're inside your picture plane, just aim between those lines. Okay? That's an in-picture method. Now, at each point of intersection, that is where you are going to place a horizontal line. And this will create your grid. Right? So there we have our grid. Okay? So far, so good. But one thing I'm noticing some of you guys are doing too, for the most part, most of you guys don't have this habit, but be conscious of it. When you're doing your notes or drawing, especially in perspective, make sure you're not just drawing like this. Alright? This distorts what you're drawing and what you're seeing. How many times have you guys drawn a figure or something that looks great when you're like this, but as soon as you go above it, it looks really messed up? That's because your perspective on it is different. Alright? You've already changed your eye level and your vanishing points that you're seeing. Your sense of depth changes. So when you're taking your notes, make sure you're above your sketchbooks and you're seeing it directly above it flat. Or as flat as possible. Okay? Now, we are going to put in the cone of vision. Can anybody tell me what the human cone of vision is? 30 degrees, okay? We are going to measure it the same way that we measured the 45-degree measuring point. Alright? We're going to measure from inside out. So we're going from the CVL outwards. I can do it this way too, if I wanted to, or I can do the left side. I'm going to do it on the right side just to keep this side a little clean for you guys. Alright, so I'm going to measure 30 degrees from the stationary point. I'm going to do this in blue. Now once again, once you get the hang of this, you don't need to always draw all of those lines all the way through. You could essentially just mark from here, tick, that's where it falls. Alright? Do I need to measure it on the other side? No, because it's a circle, right? Your cone of vision is a circle. So all I need is half. That's why I like to think of it in terms of just the radii and not the diameter of the cone. Here's where you guys may want to plug your ears. You put your compass, and that totally just screwed up that part. Put it in the center of vision. Put your lead on the tick mark and draw. Alright? And that is your cone of vision. Now, for the most part, well actually not for the most part, in this class, everything you will be doing will be within the cone of vision. Alright? The majority of your project is going to be within the cone of vision. I don't care if it bleeds out a bit from the cone of vision, but the main portions of your images in this class will be within the cone. So, you may be asking, well, if that's the case, and my grid's only like this, what happens if I drew a grid and it doesn't fall in the cone of vision at all? Well, you can just extend it. You can create more grid lines. Until the point where when you get used to it, you don't even need grids anymore. You guys really think I draw grids all the time when I'm doing my projects? No. Alright. So, here's how you add on more grid lines. And this actually helps you with multiplying things, duplicating things. This is a method that you can use. Well, if I go from this, well, if I was creating my grid lines, when I first created it, all I did was I went from my furthest corner from the 45-degree measuring point and I created a line, right? And then I put horizontals where they intersected those lines showing depth. Do you guys think it's going to be any different from the back? No, because regardless, once again, let's say if I go through these guys right here, notice they go to the 45, right? So, if that holds true there, it should hold true back here. So if I start off where the grid ends in the back, and I just go to where I need to, I now have more spots to create my grid. That's fine and dandy for going back in space, but what if we need to go over to the left? Or what if we need to go over to the right? Well, same exact thing. But all you do is this. Let's say I want to go over to the left. Well, I'm just going to take one of these, a couple of these guys, a couple of these horizontal lines, extend them out, like so. Like that. So I've got two of them. What do you think is going to happen when I go from this corner to the 45-degree? It's going to create a square for me. Right? Because if I go through this corner and corner, straight up, but if you notice, because this is outside the cone now, that's where distortion is going to start happening. So I'm still just going to go to the 45, like so. All right. It hits here. What does that do for me? It gives me a new point that I can take to the vanishing point. And I've extended it one full unit to the left. Okay? And then from there, it's pretty easy. It's just extend those guys over, over, over. I want to extend more. No problem. Here, boom. Now I got a new, now I got another one. So you could essentially build a grid from one square. Notice how I can infinitely create that grid now? Alright. Pretty easy. Not as bad as you guys thought it was going to be? No? Alright. Any questions yet? Be honest if you have any questions.
For extending it, what exactly is that? You make a line from the outermost mark to the 45-degree.
Which extension? Back in space or to the
Forward.
going like this?
Yeah.
Left and right? I just extended my horizontal lines of my already pre-existing grid. Right? So if I have two of those, that means I have the top and bottom of the square. And then if I do it next to one where I already have a line showing depth or converging in the vanishing points, that means I have the top, bottom, and the side of the square. So I just have to find the other side. So I go from the bottom corner and cut and take it to the 45-degree measuring point, and wherever it hits that top, the line representing the top of a square, well, you know that if that's the corner down there, then this has to be a corner. So you just connect that to the vanishing point, and it finishes the square for you.
Okay, I think I get that.
Yes?
Could you show how to put in the horizontal lines again? I had to start over, so I was kind of catching up when that happened.
You mean just putting these guys in?
Yeah.
Wherever this line right here that cuts through and converges to and goes to the 45-degree measuring point, just
Okay.
yeah. All right. Something to keep in mind. Something that happens a lot in perspective is people will try to overthink and overcomplicate the grid. They think it's going to be really, really crazy or a really crazy solution, but in reality, a lot of times it's the simplest solutions. Okay. So try to keep it stupid simple, KISS. Alright, so think of KISS with a long tongue. Alright, so that's how we do that. Now we're going to create a square, or a cube. Cube. Alright, but before we get into the cube, let me explain to you guys the shapes that build everything, or my theory when it comes to drawing. If you can draw a cube in here, right, you can draw any shape there is out there. Because you can fit any shape within a cube, whether it's cylindrical, spherical, angular, yada yada. You can construct them all from a cube, okay? So for example, here, I have the basis for 3 different shapes, right? I'm telling you guys right now, those are 3 different shapes, okay? Well, once I start constructing within it, there's one shape. two shapes. Three shapes. A sphere within a cube. Okay? So, quote unquote, my idea, the way I think of drawing. If you can draw a cube, you can draw anything. But to understand how to draw a cube, you have to understand how the 45-degree measuring point works. Okay? And now we know that if we cut any square or any lines or corners to the 45-degree measuring point in a 1-point perspective, then it should be a cube. Alright? And I'll show you guys an example of that after we go through this one more time. It's the same thing for the vertical. In 1-point perspective, keep in mind, 1 point's perspective, the stationary point will double as a 45-degree measuring point for vertical squares. Alright, so just like how we can cut a flat square, a square that's sitting flat, alright, from corner to corner, and we can get our 45-degree measuring point, we can do the same thing for vertical squares. Because, let's say, here's a flat vertical square. Cut corner to corner, like that. That's still 45 degrees, 45 degrees. Same as the ones, same as this guy. Okay, 45, 45. One's just standing. This one's standing, this one's sitting. Alright? This standing one, when you cut it from corner to corner, it should go to the stationary point. So, let's say I want to create a 2x2 square cube, or a 2x2 unit cube. I'm going to select 2. I'm going to select a 2x2 footprint. This is called a footprint. Alright? The beginning of your placement. Can anybody tell me why they think that's called a footprint? Anyone? Yes?
Leaves a mark.
It leaves a mark, just like when you take a step. You leave a footprint, right? Now, I want to create a 2x2 cube. There's a crazy way of figuring out the height, or there's a really easy way. The easier way for, if it's a cube, this is all you need to do. Alright? All I have to do is create the vertical walls of my cube, like so. Like that. And then, from my back corner of my cube, from my stationary point, I project a line straight up. Well, wherever it hits this front one, that front wall, I can connect it back to my vanishing point, and there's one side of my cube, 2x2. Okay? Now I can just finish drawing it. Right? So 2x2. Let's go from this corner to this corner and carry it all the way through. Alright, you guys see how it's working? So, these guys are going to go down here to the stationary point. Alright? But we can do to margin of error with human factor. Notice how I'm off. It doesn't look like I'm off by much between these two, but look at the difference in where they're going. This one's going to intersect over here, this one's going to go way over here. Alright? But the stationary point doubles as a 45-degree measuring point for the verticals. This is why it's really important to make sure your pencils are sharp. How many of you guys got that to work?
Could you go over the cube thing?
Which cube?
Like that one, the like building the cube, how do you decide how tall it is?
It's automatic. Because as soon, remember about when I answered the question about like, how did I extend the cube or the square over?
Yeah.
It's the same idea, because we've got, all we do is we extend the vertical heights based on the
Oh,
footprints,
okay.
right? So we have 3 walls already. We have the bottom and we have the 2 sides. So we just have to figure out where's that 45-degree connect, or where does it become 45 degrees? And once it hits that wall, you already know that becomes the corner. And then you just trace it back to the vanishing points. Okay? Class is over at 3:30?
Yeah.
We might go over a little bit. How many people have class after this? Alright, I'll try not to go over, but we may go over by a little bit. Because I have to get through a certain amount of information today for you guys. Alright, so that's that. Alright. Take 5 minutes, rewrite down the steps in a clear way for you guys, and then we're going to do this one more time, but you guys are going to lead me through it. Okay. Yes.
I have 2 questions.
Yes.
For this,
Mhm.
this line is like a little bit to the left
It's the human error margin.
Oh, okay.
That's why I keep mentioning human error.
Okay.
Because if you look carefully right here, look at where it's hitting. It's not hitting the corner, it's hitting like right there.
Oh.
And then it's hitting offset over here, so see how it's off the corner by that much?
Yeah.
But when you multiply that.
Okay, that makes sense. Also, I don't know what it is, but I can't get this to work very well. Like, is this about as sharp as it's supposed to get, or is
It's because it's too small. So you want to extend it out.
Oh, so 60.
You can go a little bit more.
Oh wait, that's what those small holes are for, measuring how. Okay.
So that way.
Oh.
Yeah, so of course, and now
Yeah.
it's smooth.
Oh dang. Okay, I get that now. All right.
Yep. Yes. Oh, okay.
Okay, sorry.
No, that's perfectly fine. It's, just tell me, just make it really, really visual. Because as you can tell from how, sometimes it's even really, really, kind of all the counts, it's really fast. So this is it. Like, make it where it is, no matter how old you are, your phone speed is really good.
Okay.
Just think about it, when you turn 80, are you gonna be able to read that?
Probably not.
So take this time to break down your steps. And I would go over really quick with the different colors that those other ones. Sharpen your pencils. Make sure your pencils that you are using are sharp and not dull.
Cute, isn't it cute? No, can you see it? Is it right there? Oh, okay.
Station point, back point.
Oh, okay. So it's like it's way too short and fat. That's way better. I can already see it. Thank you.
Once your eyes get accustomed to seeing things within the cone of vision, you're gonna be able to catch distorted images really, really quick and easy. It tends to happen to students probably about the third week in, where they'll start seeing it upstairs. You'll start, or on this floor, you'll start walking around, and you'll start seeing images that you originally were like, oh, that's really good, and then a couple weeks later, you'll go by and you're like, oh, that's really distorted. Right? Okay. But,
What's the line from the stationary point to the measuring point called, from the 45-degree?
from here,
Yeah.
this line right here,
Just, yes.
there's no name for it.
Okay.
Because I just do a straight line to signify that that's how I figure out the 45-degree mark.
Okay.
But once you guys get the hang of this is honestly what you're gonna see when you guys get the hang of things. You're not gonna see all of these lines. Alright. Notice how, even though it's still kind of sloppy because it's chalk, it's still a little bit cleaner after I got rid of those lines. Once you get the hang of doing these grids, you're gonna be able to do it without having to do those solid lines all the way through, and you'll be able just to go, alright, this is 45 degrees, connects here, tick, put that down. 30-degree cone of vision, mark it here, hits there, tick, draw it, you're good. Okay? But you guys aren't at that point yet. I want you guys to continue doing the straight, solid lines all the way through. Now, can you guys see the distortion starting to happen with the grid though? Notice right here how it's getting a little bit more knife edge. And then as we go in, it gets more square. Okay? If you guys look, this is also a signifier for camera cone, 45 degree, right? Because we measured 45 off the stationary point. So look at the difference in that circle range. Right? Big difference. Now can you guys see where all your camera distortion comes from? How many of you guys have wondered how figure illustration teachers can tell when you're not drawing from life and when you're supposed to? It's because of this. They can see that distortion. there's a difference between drawing something from life and drawing something from a photo. When you guys draw from a photo, especially when you're just starting off, you tend to copy the photo exactly. You don't go in and make the corrections and correct the camera distortion. That's how we can tell when you're drawing from a photo and not from life like how you're supposed to. Because we see that you guys copied that distortion. No matter how much you guys say, well, I did draw it from life that I took a photo from. Okay, that's how. Big difference. Because imagine, you guys are drawing from life like this, and then when a lot of people go in and take photo reference, they'll get closer and they'll be like that. Or they'll be sitting there drawing the figure from life right here, and then when they take the photo, they tend to lean a little bit in. Or their hands will lean forward in, so that their eyes will stay in the same place, but their camera won't be. So if you're gonna take a photo reference of a figure for future use, or to finish up a piece, if your eye's right here, bring the camera up here and pull your head back, and put the camera where your eyes originally were at. Okay? So there you guys go, 1 point. You guys ready to walk me through it?
Yeah.
Should we play popcorn again?
It's up to you.
We played popcorn last year, that was kind of fun. I know, something else in your class last semester. Should we do popcorn again? It's where one of you guys start off on the grid and then the rest of, and then you call someone else and then they have to do it for the next person, next. Alright, you guys ready for your freebies? I'm gonna give you guys 2 freebies right away. Your CVL, which is a representation of what? The center of vision, correct. And my eye level or horizon line. Can they be the same thing?
Yes, they can.
Are they the same thing?
No.
Good. All right. You guys ready to start? So, what is the center of vision?
For the
Center of your vision.
center of vision is where the camera is standing and where it's looking at, or where it's like how high it's standing up. The point, and the vanishing point of one single.
The point of convergence? Alright, yep, your center of vision is the vanishing point. Where's my center of vision?
In the center.
In the center of the chalkboard, right here.
Not in the center of the chalkboard, it's in the center, it's where the eye line and the horizon line meet. Or no, excuse me. Oh my gosh. The vertical line and the horizontal line meet.
Okay, where they cross or meet. Alright, so is that the right acronym?
So,
No. What's the COV? Cone of vision. As you guys notice, I am now playing devil's advocate. What does the CV double as? Vanishing point. Measuring point? You want measuring point?
vanishing point.
Okay. Alright, what's the next step?
5 units down.
Does it have to be 5 units?
Doesn't, but that's like the decision.
That's the decision. I like that.
Good
Alright.
start.
It's a good start. 1, 2, 3, 4, 5. What's next?
Within
unit, draw the
measuring line.
Establish the ground plane and measuring line, okay? Somehow I heard that through everything. At least you guys are all talking. So what do we wanna do now?
There's 5 left. 5 units left in there.
5 units left, 5 units right? Alright, next.
From the, ground plane, draw 3 more units down to create your stationary.
Alright, does it have to be 3 units?
No.
Nope. It's whatever you need, right? It's whatever you need to tell your story. Man, you guys are being lazy with this though. Yeah. What's next?
Measure 45 degrees from the stationary point.
Alright. Can I go left or right, or does it have to be left?
It can be either
It can be
way.
either way.
Either one. Good. See, once you get the hang of it, you don't need to do that all the way.
That's wrong. Isn't it empty? Measuring point?
Good. Good. Next.
Draw a line from measuring point to the deep right corner on the ground plane.
Alright. What's a method I can do when I can't reach it?
In between.
Aim in between. Alright, next.
Connect points on ground plane to the measuring point.
Connect the what?
Points on the ground plane to the measuring point.
Alright. What's next?
With the measuring line and the lines from the vanishing point to the ground plane intersect, draw a horizontal line.
Alright, so at these points? Alright, good. What's next?
Use your 36 and 90 triangle to establish a point where you can establish that point of vision.
So like this?
No, 30 around that.
And you guys have successfully led me through creating a grid. Not that bad, right? How many of you guys thought this would have taken you guys like 2 weeks to figure out? None? Good. How many of you guys thought it was going to take longer for me to teach you guys how to do a 1-point grid? Okay. Good. It's easy. Not that hard. Alright? At least for the bare basic of it. This is where we're going to stop with the 1-point grid. Does anybody want to take a photo of this before I take it down? No? Good? Alright. Go on. 2-point time. So in 2-point perspective, there's a rule. Besides the fact that there's 2 primary vantage points. The rule is there are 2 given, the rest is, or 2 random, the rest is given. Okay? 2 random, rest is given. This is one of the biggest rules to remember in 2-point perspective. In a sense, with 1-point perspective, 1 is random, the rest is given, right? In 2-point, 2 is random, the rest is given. So what do you think it's going to be when we get to 3-point perspective? 3 randoms, the rest is given, okay? So, once again, I'll walk us through 2-point first. Take visual notes of it, look at it, watch me do it. If you want to, go ahead and jot down little notes. But for the most part, I want you guys to keep an eye on me when I'm doing it. Alright? Keep an open ear to listen to what I'm saying as well. And then, second time around, again, we're going to go through it together. And third time, you guys are going to lead me through it. Alright? So 2-point perspective. Center of vision line stays the same. Okay? Nothing different about that yet, right? My horizon line. I'm gonna drop it a little lower, make it easier on you. My horizon line / eye level. Nothing different about that yet, right? This is still my center of vision. Anything different yet? None?
No.
None. Everything's still the same, so far. Now, I'm going to do it this way too. Just like in 1-point, we can start off with the height of our camera. So let's make it 1, 2, 1, 2, 3, 4, 5. And then what was our stationary point for the 1-point again? It was 3?
Yeah.
Alright. So I'm gonna draw that exact same 1-point grid, but as a 2-point grid. Same dimensions. Alright? So our ground plane is still 1, 2, 3, 4, 5 units down. And this is still my ground plane / measuring line. This right here, my camera, or my stationary point, is still 3 units down, right? Because I want it to be, I'm essentially drawing the same exact grid we did before, okay? By me doing it this way, what am I showing you guys? What do you think I'm showing you guys how to do by doing it this way, by keeping the exact same format, or the same grid numbers? How to draw a room in 1 point and rotate it into 2 points. It's the exact same room dimension, but we're just rotating it. Okay, that's it. So nothing's different yet. I'm gonna go 5 to the right, 5 to the left, like before. Okay. 5 to the right, 5 to the left. Still pretty simple, right? Technically, none of this has been given to us. All of this is still kind of random. Well, actually, this was random, stationary point. Why? Because we chose it to be random. Okay. Now, I am going to choose my vanishing points. With 2 vanishing points, keep this in mind. As one vanishing point gets closer to the center of vision line, or to the center of vision, the other one gets further away, okay? So as one gets closer, the other moves further away, all right? This is a definitive. This is something that is absolute. This will always happen, unless you have 2 evenly spaced vanishing points, which can happen. But unless they're evenly spaced, this will always happen. As one gets closer, one gets further away. For this reason, if you have any pairs of vanishing points, any corresponding vanishing points, okay, they will always meet at the stationary point at a 90-degree angle. Remember the angles I told you guys about. 30, 60, 90, and 45. Those are the 4 biggest angles that you'll hear over and over and over again. 2 vanishing points will always meet at the stationary point at a 90-degree angle. So what that means is if I place vanishing point 1 over here, okay? My vanishing point 1's over there. Well, if I see that vanishing point 1's right there, I have my 2 randoms, VP1 and stationary point. Those 2 are my randoms. Now everything else is being given to me at this point. Vanishing point 1, stationary points right there. Well, if they vanishing point 1 and vanishing point 2 create a 90-degree from the stationary point, that means I have to connect vanishing point 1 to the stationary point, like so. And then to find vanishing point 2, it is automatically given to me. Because now, I have to create a 90-degree angle using this line and the stationary point. So, I put my 90-degree corner on there, so it's flat against it, and now I have to project 90 degrees. Straight, all right? And now, I've been given finishing point 2. So these 2 meet at a 90-degree angle. Anybody lost on that? Everybody's pretty good with that? Right? Now, in 2-point perspective, we have a different type of measuring point. We do still have a 45-degree measuring point that we can use to help us figure out a square. I'll show you guys how to find that right now. To do that, instead of projecting 45 degrees from a stationary point like this, you now have to split this 90-degree angle that's being formed by VP1 and VP2 in half. Okay, so just like how we figured out 90 degrees by lining up this flat edge with the SP, we now have to line up the 45 degree from the stationary point with a flat edge on one of those lines. Okay, this is effectively dividing this 90-degree triangle in half to create our 45-degree measuring point. In 2-point perspective, the 45-degree measuring point is not as important because what this is going to help us do in 2-point is just increase our grid. That's pretty much it. It helps us increase our grid, or it helps us find squares or units of measure that are even. Okay? But you guys, anybody confused on how I did that? No? It's just splitting the square, or it's just splitting the 90-degree formed by the vanishing points at the stationary point. That's it. Easy. Now, I'm going to find the measuring point, the other measuring points. These measuring points correspond with each vanishing point. There's going to be a measuring point 1 and a measuring point 2. Okay? These are what we are going to utilize to help us carry our units of measure onto our pipelines. Right. To find our measuring points, what you are going to do is you are going to take the distance from the vanishing points, the vanishing point to the stationary point distance, and swing it up, pivot it up onto the eye level. Okay, you see that? I took this distance and then swung it up. Anybody confused about that? No? Alright. We need to do measuring point 2. Measuring point 2 is the same. Alright? From the vanishing point, distance from the vanishing point to the stationary point, swung up. This is why your compass is important. It's not just for creating the cone, it's for helping with this. Right. Now, I kept mentioning pipelines. What are the pipelines? Pipelines is just my name for a measuring line that we're going to be using. But imagine if we kept this as measuring line and then we had measuring line and measuring line. That gets a little confusing. So, we are going to create pipelines. What pipelines do is they are measuring lines that are created when you draw a line from the vanishing point and intersect through the endpoint, the nearest point. You guys remember the endpoint? And you carry that all the way through to infinity and beyond. Kind of like Buzz Lightyear. Alright? Yes, I make a lot of Disney references and so on and so forth. I can't help it.
Say it like it's bad.
So this is pipeline 1. Why is it called pipeline 1? Because it's coming from vanishing point 1. Alright? Pipeline 2. Same thing, but it's going to be from vanishing point 2 through the endpoint. Like so. Alright. Now we can start creating our grid. Alright? How many of you guys can kind of see the 2-point forming? Alright. This is where these measuring points, these vanishing points, and these pipelines start working together. And this is also where a lot of people start messing up with 2-point. Okay? We have to transfer these unit of measures on the ground plane's measuring line onto these pipelines. Alright? To transfer these unit of measures onto pipeline 1, you're going to use measuring point 1. Okay? Remember, the 1s go together. The 2s go together. To make this easy to see, I will use a different color. So we'll start transferring these unit of measures onto pipeline 1. It sounds like it's not that hard to get next, or it sounds like it's really easy to remember, but this will happen. People will just get into the groove of it, and they'll start using measuring point 2. But it's measuring point 1. Measuring point 1 corresponds with pipeline 1. So I'm going to go through each one of these tick marks onto that pipeline. And I'm going to carry it through these as well. Alright? You guys with me at that point? Now I'm going to do the same for the other side. So I'm going to carry the units of measure from utilizing measuring point 2 onto pipeline 2. So tick marks, this is pipeline 2 right here, measuring point 2. So, now I have these points of intersection, where these units of measure are intersecting my pipelines. In 2-point perspective, there are no longer any perfect horizontals. All horizontals and all lines that show depth in 1 point are now converging to vanishing points. The only thing that are perfect in 2-point perspective are verticals. So the only straight lines that you should have that do not converge anywhere are verticals, unless you have a 1-point object on a 2-point grid. Okay? So now, at these points of intersection, I'm going to take them to the vanishing point. So, look at considering we all read left to right, okay? Which direction do these guys look like they're going? They're leaning more towards the right side, right? We're gonna draw a line from vanishing point 2 to these intersecting points on pipeline 1. And I'm gonna erase all these other lines so it's not as crazy looking. And I'm gonna stop there, because once I go to that point, it's pretty outlandish. Now I'm gonna connect the other side. So from these guys, I'm gonna connect to vanishing point one. Okay? You guys see your 2-point grid now? If I did this, if there is absolutely no margin of error, which I haven't been having a lot of today, then I could essentially draw a line through any one of these square corners and connect it to the 45-degree measuring point. Okay? So this is a good way of how to check, to see how far off you are when you're doing your grid. Not that bad, still pretty bad, but not that bad. That one's better, alright? But that's how I could do it. But if you look carefully, look, I've already created a new point of intersection where I can add on to my grid now. Right there, and as soon as I put in this line, it'll create a new point. And then it just continuously repeats over and over, and now I have an infinite amount of grid squares I can create. So that's 2-point perspective. Alright? The cone of vision will still come from the stationary point onto the eye level. That doesn't change. That will still be the same. Questions yet? No? Alright, you guys ready to do this together? Alright, so set up your CVL, your EL, and that's that.
Itchy.
Yes.
For 2-point, that would not be the horizon line then, just the eye level.
Nope, still your horizon line.
Okay.
For the most part, 1-point, 2-point, the horizon line, I look the same.
Okay.
It's in 3-point where it changes. And you guys will see it when we get to 3-point, which will be the last 4 or 5 weeks of class. Because we got a lot to teach you guys in 1-point and 2-point. I'm going to teach you guys spiral staircases, ellipses, XYZ drawings, which will help you guys understand, which will help you guys with drawing vehicles, creatures, stuff like that, insects, those are fun. We'll be doing reflections in here, I'll be shadow projections. I'll be doing like a value demo too, just like a basic introduction to values for, not like crazy made up values, but it's just like a general rule of thumb for values. And it's going to be so simple to the point where people were like, really, that's it? So, yeah. And now, because I remember you're Josh, right?
Yep.
Yeah, I remember seeing your name before, but I couldn't remember where.
Yeah, I was here for like a day,
And then
you dropped it.
Yeah. So we're going to keep this grid smaller and simpler for us. just to make it easier on you guys. And on me. Alright, center of vision. I'll let you guys do this though. Do you guys wanna start off with a vanishing point, stationary point, or do you guys wanna start off with the two vanishing points first?
Stationary point.
Stationary point, keep it same. Alright. So, let's go. We'll go 5 down for the ground plane, and then we'll go another 3 for the stationary point. So we'll keep it the same right there. Okay. So everybody's with me at that point? Next up. We'll put 4 to the right, 4 to the left, shorten it by 1. Everybody's good? Alright. Now let's put in the vanishing points. So I'll put 1 vanishing point over here again, but I'm not gonna go as far. I'm gonna go about right here. That'll be VP1. Yes.
So vanishing point is just wherever we want it to go.
Yep.
It doesn't have to equal 90 degrees?
Not yet, because this is still the first random.
Okay, but the second one has to equal 90 degrees for this. Okay.
Yep. That's why the rule is 2 random, 1, and the rest is given.
Okay.
So essentially, the stationary point is kind of random. So imagine if we were doing this as a thumbnail, right? And we want it to be somewhat correct in our thumbnail. It would just be me. It would just be us doing this type of thing, like boom. It would be that type of thing to make sure that your grid's at least, to make sure that your thumbnail grid is at least somewhat correct, and then save you more time when you're blowing it up and making it better.
Okay.
Yeah. Put it this way. At this point in stage of the game where I'm at, only reason why I still review a lot of these really formal ways is because I'm teaching it to you guys. Because nowadays, if a client really needs something super, super specific like this, there's 3D programs now that you can get all your dimensions off of. But let's say on the off chance that you get hired to an architecture firm and you don't have access to any of the computers and stuff, and you have a client who's like in a rush, right? Well, what are you gonna do? That's what you gotta do. Or if you have a drawing and a client's like, that's awesome, can you redraw that where we're looking at it from this angle instead? What are you gonna do? If you don't understand how to do this, then you're gonna be fumbling your way through, and it takes like 3 times as long to fumble your way through unless you, but if you know how to do this, then you'll be able to go, alright, no problem, there, alright, my camera's over here, I know exactly how far everything's gonna look, and I know what's gonna be in it, what I wanna show. And I'll be showing you guys how to do that too. That's a floor plan perspective. Okay. So, we will figure out vanishing point 2. It's by connecting vanishing point 1 to the stationary point. I'm gonna be a little more accurate. Oh, occasionally, you'll get coincidences like this where your line may cross through a tick mark. That's just a coincidence. Unless I say unless I say that it happens, just take it as a coincidence. Okay? Alright. So now to find vanishing point 2, it's 90 degrees. Like so. And now I've been given vanishing point 2. That's cool. Everybody's with me on that? Those actually work really well for the very things. Here, I'll show you my sharpener. This is my pencil sharpener. It's meant to cut through drywall. Now we're going to swing to find our measuring points. So, the measuring points, alright, so essentially it's this. The vanishing point, here's your first equation for perspective. Vanishing point plus stationary point equals the distance, alright? Now, the distance plus the vanishing point equals the measuring point. Alright. So this, remember how I told you guys it's a little bit scientific in a sense where you can kind of break it up into equations and formulas. What this tells you is that if you take the distance from vanishing point 1 to the stationary point, hence vanishing point plus stationary point will give you this distance. Let's say you don't have a compass, right? And all you have is like a sheet of paper. You can take that distance like that, right? And then you add it to your vanishing point right here, put it down on your eye level, and that gives you your measuring point. Does that make more sense now? So,
Yeah.
vanishing point plus the stationary point, that distance add it onto your vanishing point, and wherever it falls on your eye level, that is your measuring point. Or just vanishing point to stationary point, swing up. Two different ways of thinking of it, about it. But I want you guys to be flexible. I want you guys to be able to think interchangeably. After you're done with measuring point 1, you're going to do the same for measuring point 2. So vanishing point 2 to stationary point, swing up. That gives me measuring point 2.
Make sure we go home, read like the notes that they're super neat, because then what else on that earlier? Imagine if you were able, would you be able to use that? What was that?
I guess I just don't understand how to use a compass. How do we make the little rounded marks from the measuring point to the station point?
The sweeps that I got,
Do we just freehand those?
I can
Maybe
do
it's
it
a compass?
because I know how to do it. But it's just something the vanishing point to the station point.
Oh, okay, that makes sense.
Something, let's make these extend out a little bit more, sometimes you have to pop those out. It's almost like- Make sure you guys, I see a lot of you guys not including that line, this arc, to represent the measuring point. Make sure you guys do that on this first one. Include it onto your notes so that you guys can visually see what you did. I guarantee you guys, a lot of you guys are going to forget how to find it. Yes.
So does it also work like I'm measuring where this comes up and then it just brought it up?
Yep.
Nature. Same thing?
Yeah, that's essentially what that equation is.
Okay, cool.
So, it makes it two different ways of thinking. This method right here is the way that I do it when I'm moving the right now, just like, all right, boom, boom, flip, swoop. If you guys have to, do it this way when you guys are making down the notes. Use arrows that follow along the line, like so, and then do like the swoop. That will help at least clarify what you guys did, okay? Remember, these notebooks are only as good as you make them. But I'm gonna try to help you guys make them as good as possible. Now, I want you guys to put in the pipelines. So, the pipelines extend from the vanishing point through the nearest point, the end point. So basically where the ground plane intersects the center vision line. That's pipeline 1. Pipeline 2. Same thing, but opposite side. Alright, everybody's good? Now, let's transfer those units, these unit measures, onto the pipeline. So, pipeline 1 with measuring point 2. Yes or no?
No,
No, good. Which measuring point do I have to use for pipeline 1? Measuring point 1, correct. Now we're going to do the same for the other side. Measuring point 2 with pipeline 2. For those of you who are using the same colored lead over and over and over again for it, make sure you guys get in the habit of using different colored leads until you get used to it. Because if you're not used to it, you're gonna get confused. Alright, for those of you who have all your unit of measures on there, feel free to connect them to your vanishing point. So, the tick marks that fall on pipeline 1 go to vanishing point 2. And then the unit of measures that fall on pipeline 2 go to vanishing point 1. And there you have your grid. Once you guys are done with this, take 5 minutes, write down the steps in really clear, concise orders. Okay? Write it down in a way that you'll remember it. And then we'll do it one more time, but you guys will be taking the lead. Any questions about the 2-point? If you have not put in your cone of vision yet, go ahead and put in your cone of vision. It's 30 degrees from the stationary point onto your eye level. And then use your compass and draw it in. You'll see the distortion happening.
Man, you gotta redraw that.
You have a straight edge or something? opposite, different colors. Good, good. Alright. So, you guys ready to walk me through this? Yes?
Yeah.
Yeah. How many of you guys feel less confident about this one in comparison to 120? And we'll cover the how to extend the 2-point grid after we do your guys's, alright? So, the freebies again. CVL. EL. Alright. What's next?
Establishing a ground plan.
Alright, how far do you guys wanna go for a ground plane?
4.
4? Four. Alright. 1, 2, 3, 4. There's my ground plane. How many units do we wanna go left and right?
5.
5? Alright. What's next?
I think we need stationary.
Stationary point? How far down do we wanna go?
Since we're going shorter, let's do 2.
2? Alright. What do we wanna find next? Vanishing point? Alright. Which one do we wanna do, left or right? Left? Do you guys wanna put it closer to the center of vision or further away? Closer? Tell me when.
There.
That's close. Alright. So there's our first vanishing point. What do we have to do now to find vanishing point 2?
90-degree angle and then also subtract from 90.
Alright. Did you seriously just tell me measure the whole angle and subtract it from 90?
Yeah.
That's one way of doing it. That is one way of doing it. My way's a little easier. Connect the vanishing point to the stationary point and just project the 90. I like to do this simple. Now, let's say for extending the grid, we need what? What do we need to extend the grid when we've created it? Anybody tell me? What is it that I need to extend the grid? It's a specific measuring point. Anybody?
Is it the marking point?
No? Measuring point?
The sun.
What do I need to extend the grid?
45.
45, there you go, 4, 5. 4, 5. How do I find the 45-degree measuring point in 2-point perspective? Split the 90, yep. Splitting the 90. Alright, so, what's next?
And then from the stationary point, you start from the vanishing point and then you drag it upward. Or is it-
Alright, and what's that called?
That's called the marking point.
Not marking point,
Measuring.
measuring point.
Excuse me.
Is that supposed to be switched?
Mhm. I saw your eyes catch it, you were just like, wait. Alright, what's next?
And from the, oh yeah, you find the pipelines from the vanishing point. They have to intersect oh gosh, the name for it, the baseline.
Baseline? I don't have a baseline.
No, they have to intersect the measuring point.
Measuring point?
It's the ground plane.
Ground plane.
Plane, excuse me.
Correct. Wow, that is a terrible line. Now that is not confident. Alright, what's next?
From the measuring points, you draw lines to the left and right markings from each measuring point. Try and find the two first.
So which one goes with which?
Which one goes with
Point
which?
two
Oh,
goes with,
one goes with one, two goes with two.
One goes with one, two goes with two. Good. One with one. Next.
Connect the intersecting lines that run on both pipelines. So example, the tick marks on pipeline 2 will be connected to vanishing point 1.
Correct. Alright, so there we have it. Now, let's put in our cone of vision. Right, so cone of vision is what measurement? Human cone,
30 degrees,
30 degrees. What's the camera cone?
45 degrees.
45 degrees. So human cone. 30 degrees. So there's our cone of vision. What's the acronym for cone of vision? COV. Alright. Now let's extend the grid. Right? Let's extend it left and right. This is where you wanted. This is what some of you guys wanted. So, what's the rule about a square when we cut it in half? In a diagonal.
Was 245 degree angles and
2 45s, right? So, how do we cut these guys into 45s? Just go from the corner to the 45-degree measuring point. Easy peasy. Because this is a measuring point. This measuring point here gives us the 45-degree angle. Because these two vanishing points technically represent two angles when they meet up, they create a 90, right? So, since we split it in half, this line here represents those two corners being cut in half. All right? That's why this works the way it does. So, let's split. Let's extend this way. So I'm going to go from this corner to the 45, like so. We'll extend this way too. So I'll go from this corner to the 45 as well. If you look, we've already have new grid marks. Now from those points, all we do is we just connect them to the vanishing points. Like so. And the same thing for over here. And if you look, we continuously have new, more and more marks that will allow us to continuously increase the grid. Easy? Pretty simple, alright? So, nice job. You guys got basic 1 point and basic 2 point today. With 30 minutes to spare. That's not bad. Yeah, I think last year we went almost over.
Yeah.
Nice job. How many of you guys feel better about the coming semester with this class now that you guys have been through one? Alright. Today and next week are probably the hardest class periods. Just because all this information is so new to you guys and so foreign to you guys that you guys don't really understand the phrasing, but now you guys have a better understanding of phrasing. So, hardest day, today. From this point on, it gets easier and easier in a weird sense, but then some of the theories get more and more complicated. Okay. Not bad. Not too shabby. Alright. Where did my eraser go? There it is. Now, let me show you some other ways of doing 1 point grids. Just to show you guys how flexible it can be, alright? So these next couple methods, I just want you guys to watch me, how I do it. Just to show you guys how free form I want you guys to think about perspective, okay? So we've already done it where it's in a really rigid format, right? Where it's like CVL, EL, stationary point, this many units down, so on and so forth. Here's a more freeform thinking. CVL. My EL, horizon line. CV, VP, this is 1 point. I'm going to start off a little different than you guys did. I'm going to use this to create my grid. How many of you guys think that's a square? 1. How many of you guys don't think it's a square? Why don't you guys think it's a square?
I guess it could be at some point down there, like deeper in the background.
So you guys don't think this is a square right here? I'm just asking.
It's not like a perfect square.
What if I told you guys this is a perfect square for my grid right now?
Is it like it's distorted where it is now?
It's distorted,
Yeah.
but it's a square.
Deeper in,
And now I'm going to show you guys how we can find a grid just based off of this one square. Because what do we have to find in 1 point perspective? We have to find the 45-degree measuring point and the stationary point. There's my 45-degree measuring point. Now I'm going to find my stationary point from here. There, my friends, is my stationary point. Notice how I did that? I came up with the statement that this is a true square. If that is a true square to the world that I am creating in my imagery, right? Then if I was to cut that square in half to create a diamond, that is going to give me a 45-degree measuring point that is true to this world I am creating. And we know the stationary, when we find the 45-degree measuring point, the more systematic way, right? We measure it off of the stationary point. Well, if I can do it that way, doesn't it mean I can do it the reverse way? Yes, so that's what I did. Push it down that way. Now, I have the information I need for my stationary point or for my cone of vision, which in this sense is small, so you are correct. It is very distorted for where it should be. And that is the reason why it's so distorted, because it's not even within the cone, right? But now, I can create a whole grid based on this, because all I have to do is go from this corner above it, connect over. Now I have a new grid mark here. I now have those, but how do I get over here? Well, there we go. It's already intersected that horizon, or that horizontal line. So in this instance, the CVL no longer acts as part of those lines that showed that, okay? But I now have a grid that can be continuously built upon with just that little bit of information. So here we go. There's that corner. This one goes here. There's that corner. Now I got more info. And my grid is being built. I've just built a formal grid with nothing more than a square. So you guys see how freeform I want you guys to kind of take perspective? It helps you relax a little bit too, because it's not as like number oriented. Because as visual people, we're not very number oriented, not at all. Although I loved math when I was in high school and stuff. Okay. But that's one way of doing it. This is how I would reverse engineer out of a thumbnail for a 1-point image. If I had a 1-point thumbnail, I would look and try to find my eye level, my CVL, my center of vision, and then I would try to find what's a square. As soon as I establish what's a square, I use that to find my 45 degree, and then the rest of it's all there. And then from there, I can fix everything and make it look like it belongs to the piece, even if it's a 2-point object. Because now, I have my stationary point. So let's say if I had a 2-point object in here, right? So let's say I had a random object alright, so this becomes my RP1 because this is the random one side of my object. How do I find the second RP? Well, it's just like any corresponding vanishing point. Connect it to the stationary point, project 90 degrees, where it hits the eye level, that is the corresponding reference point. So now, I now have, bless you,
Thank you.
I now have a 1-point grid with a 2-point object. Okay. See how I can use them interchangeably now? The same idea of building a 1-point grid off of this square, you can use it in 2-point as well. Right? And I'll show you guys an example of that as well. So let's say we had a thumbnail, and figured out the eye level. And the horizon line, right? So I'm gonna do my two randoms. BP2. That is not my stationary point. Now I have to find where my stationary point is. To do that, I have to find out where these two meet at a 90 degree. This is where you have to jury-rig something together. Yep, about right there. Okay, so using that, I have found my stationary point. Because I just used both vanishing points and figured out where they met on the CVL at a 90 degree angle to create my stationary point. Now, let's say I want to turn this into a grid square. Well, to do that, I have to find my 45 degree measuring point. To do that, I have to split this 90 in half. There's my 45 degree measuring point. I now go from the corner of my square, go straight to that. Now I can create a grid square of any size, and once it intersects that line, I know that's the other corner. So I'm just going to say it's this big. Go like that. There's that guy. Like that. I need a little bit more information. So that's easy. Let's do it this way again. I've got that. And I'll do this side to get 3 solid information. And now I have a grid that will continuously be built. Okay. Not as bad as the other way, though. And I know that it's correct. It's formal. Right. Okay. So that was your guys' first day of perspective. You guys are done with it. Now we gotta go over the homework. And my pants is covered in chalk. This chair sucks. I hate these short chairs.